Deep is an oceanic exploration and technology company. We were founded in 2021, but we just came out of stealth in September of 2023 because we wanted to work and make sure that we're able to kind of deliver this in a viable and economically feasible way as well. Through this, we're looking to create and revolutionize the platform that really changes generationally how humans access, interact, and ultimately understand the ocean. Now, at the core of this is our habitat system called Sentinel. Now, habitats are not a novel concept. They've been around since the 60s with Conch Shelp, with Jacques Cousteau, with Jan Koblick, with La Chalupa, and the last one was the Aquarius Reef Base built in 1986. What we've looked to create is not just a marginal improvement in habitats, but a leap in habitats. So this habitat is the size of a Boeing 777 if it were cut in half. It can house a crew of 6 in depths of up to 200 meters, either at ambient pressure or single atmosphere. And what this allows people to do is to go down there for a period of up to a month and have that fluid interactivity with the ocean. What it allows people to do is buy time. Again, time down there, less sensitive to sea states in terms of our ability to access the ocean, to conduct that research in situ. So going out, sampling, bringing it back, and doing that work there in the Sentinel. The other kind of key areas that you've kind of seen this innovation as well is the modularity. We can take these habitats with their own life support systems built within it. That's a key design tenet. And we can see that modularity where they're able to be put together and to have what we call super spans. And they're also redeployable. They're not propelled, but they can be redeployed once you've seen that particular area in terms of the areas of interest have been exhausted.
Sounds exciting. So what are these structures made of?
So these structures are made of mild steel with an Inconel cladding. We went and looked at the traditional fabrication techniques when we set out to do this a few years ago. But looking at issues in terms of geopolitics and the way that's unfolded, looking at issues with the supply chain because of COVID, we wanted to be in control of our own destiny. And looking to kind of drive that supply chain resilience and security, we effectively stumbled across advanced manufacturing, in particular wire arc additive manufacturing. And that allows us to kind of catch on to a few different trends as well. What we find is because you're building up, you are actually reducing your carbon footprint by quite a bit rather than breaking things down. So the energy usage is much less, and it allows for more kind of bespoke types of designs. So again, it's really it provides a lot of opportunity in the marine space, and that's something where we've been at the forefront. So we'll have 3-meter tall robots with wire coming in and have 6 of them working in concert. So again, the application of that technology in the marine space, we're one of the few, if not the only, doing that at the moment.
So this sounds very futuristic. What kind of timescale are we talking about here?
So we've been at this for some time. So we're pretty much at that stage of melting metal. We have over 70,000 engineering hours baked into this project. So we're going through the final stages with the class society because this will be the world's first classed habitat. So we're going through the final stages now in terms of that manufacturing facility, getting that stamp of approval. And then we'll begin to start melting that metal and building these structures in the beginning of 2025. Now going through the appropriate class approvals as well, going through the factory acceptance test, the harbor acceptance test, and the sea acceptance test, that will take time. When we have the first one deployed in the ocean, it'll be 2027, so on this side of the decade. The potential for the system is what we want to do is we want to blaze that path. Right? If we are successful, we should see other technologies emerge from this permanent presence of humanity on the seabed. The applications are also abundant in terms of the kind of the cross-sectoral benefits. The natural ones is you look from a scientific perspective, right? So you see all the different kind of organisms and animals that are in the ocean, and they're swimming in a sea of bacteria and so forth that are either trying to make them a meal or a home. But through those chemical processes, those biological processes, they either repel them or absorb them. Now, what we can learn in terms of the applications for healthcare and life sciences are abundant, but also looking from the perspective of the carbon cycle and climate change. The ocean is the heart and lungs for the planet. The oxygen for at least every other breath you take comes from the ocean, not the rainforest. And the importance in terms of that heat exchange from air to surface of the ocean is extremely important from a meteorological perspective, and also the climate cycle as well. So again, being able to run controlled experiments in this dynamic system continuously is going to greatly raise our understanding of the ocean, and ultimately that kind of observation will drive scientific discovery, which will benefit humanity for years and years to come.